Alright guys, the matrix projects will be a bit longer than usual, but I will show you some very interesting things, so hold on. In this project we will work with monochromatic or black and white images. Do you know what images are? That's right, they are matrices. We will both create our own image and also use an existing image to work on, so we have the following tasks at hand. So let me comment them. Alright, so first we have to generate a random image 500 by 500 pixels and visualize it, and we will go through the points one by one when we get to each of the points because they will be pretty long. Now we will use the round-eye function to generate our image. Images are represented by numbers between 0 and 255, where 0 is pure black and 255 is pure white. Everything in between is a gradient of the gray. So every pixel of the image has a different gradient of a given color. In this case, this is the white and black. So our black and white image will be round eye of 0 to 255. So these are the limits of our numbers that we're going to generate, because these are the values for the colors. Like I said, 0 is pure black and 255 is pure white. Everything in between that we get will be some form of gray color. Then we want to make the image to be 500 by 500 pixels. So every element in the matrix that we're going to generate is one single pixel. So if we have a 500 by 500 matrix, that will generate a 500 by 500 image. So 500 by 500. And there we have it. Now, in order to visualize this matrix that we are generating, we have to use the function called IMShow, and we have to give it this matrix, so black and white image. But of course nothing is that easy and we will need some extra steps, so let's first see what are we getting. Now let's run it, and as you can see down here, we get a 500 by 500 matrix. We also get some white image, and as you can see we have some tiny black dots here and there, but there is no gray. We only have white and black, and mostly white. This is because we have to convert the generated matrix into a grayscale image, and to do this we are going to use a function called mat to gray. So image to grayscale, mat to gray, and we have to give it the matrix along with the color range. So black and white image 0 to 55. Let's try again. We also have to use the newly generated matrix for the IMShow, so let's run it, and there we have it. As you can see, now we have an image. It's just like a TV when it has no signals. You just get some static noisy image. So as you can see here, now we have different gradients of the gray. We have black, we have white, we have everything in between pure black and pure white. So this is the image that we just generated. Now our first task is now completed. The next thing that we have to do is extract the pixels that have a gradient over 180 and visualize them. These will be the pixels that are mostly white, so we will get an image that is mostly white. Now let's do this. So we have to start with logical selection. Mostly white image equals. We are going to use our initial matrix, so black and white image, and we are going to extract from it all its values that are above 180. So black and white image above 180. Let's run it, and here we have an issue. As you can see down here, we get a vector. We don't get a matrix, we get a vector with 73,000 elements in it in one single giant column. And this is normal. We don't actually have another way of doing this because the values that we're looking for are not next to each other. They are spread over the whole matrix. They can't form a matrix by themselves. That's why MATLAB returns a vector, and we need to turn that vector back into a matrix. To do this, we're going to use a function called vec2mat. So mostly we're going to create a new variable, which will be our actual matrix. So mostly white matrix will be equal to vec2mat, and we are going to give it a couple of arguments. The arguments are first the vector that we want to transform, and the second is how many columns we want this vector to have. So mostly white image, and here things get a bit tricky. Now we have 73,000 elements. We want to generate a square matrix. We need to find, when we square, what number do we get 73,000. So we need to take the square root of the length of the vector, and if we try it here, so sqrt of length of mostly white image, we get the number 270. 270 by 270 will be our square matrix in this case. The problem here, another problem, is that we don't get an integer image, we get a floating point image. We only need the 270, we don't need the point something, but I will leave it like this so that you can see what is the issue with the floating point number. Now, sqrt of length of mostly white image. So when we do this, we use the vector and we say, alright, take this vector and create 270 columns from that vector. Since 270 is the square root of 73,000, we are going to get 270 columns and 270 rows, which will be a square matrix, or it should be. And finally, we have to visualize it. To visualize it, we have to convert it to grayscale, so mostly white grayscale equals to math to gray of mostly white matrix, and again the color range, and then we have to visualize it. I'm show of mostly white grayscale. Now we are not going to be able to see both of our images because we have to use another function in order to view both of them, but we will see the one that we are interested in. And as you can see, we actually couldn't even see it. We immediately got an error saying that mat column must be a positive integer. The keyword here is integer. Like I showed you, the square root returns a floating point number. So we have to round it, and we're going to use the floor function to round this number. The floor function, now if we have the number 270.9 and we floor it, we will get 270. So the floor function rounds a given number down to the nearest integer down. We can also use sail, the function sail, from short for sailing, which will round it up. In this case, we want to round it down. So floor and the bracket on the other side. All right, let's try again. We deleted some. Let's try again, and there we have it. There we have it. As you can see, we get an image. What is its size? 272 by 270. This image, as you can see, is mostly white. It has gray in it, but it's on the whitish side of the gray color. And down here at the bottom, we have a black line. The reason we get this pure black line here is because we actually don't have enough elements in our vector to generate a true square matrix. So when we generate this image, as you can see, now we got a bigger black line. Our vector ends here, and in order to finish the generation of the matrix, MATLAB is adding zeros at the end of this row. So what we can do to fix this is we can delete the last row from that matrix, and we're going to do that before we convert it to grayscale. So we're going to say mostly white matrix equals to mostly, basically we are going to, let's run it again. Basically what we're going to do is we are going to select everything. So we're going to select the whole matrix without the last row. We're going to select everything, but we're going to skip the last row. We're going to delete it. So let's finish it, mostly white matrix. We're going to select all rows, so from 1 up to the end, -1. So we're going to select all rows except the last row. And we're going to select all columns. Let's try it like this. And it's working. We no longer have the black row down here, but our matrix is still not a true square matrix. So how are we going to fix this? In this case, instead of deleting one row, we had to delete 2 rows, because without deleting this row, we had 272 by 270. To delete the correct amount of rows, we must subtract the difference between the two sizes from the end. So we have to actually make it from 1 to end minus the first size minus the second size. So it will look something like this: size of mostly white matrix of 1 minus size of mostly white matrix of 2. And if we try again, all right, what is the problem here? Oh, we are missing a bracket. All right, and there we have it. As you can see now, 270 by 270. If we try a couple of times, we will probably get different results at some point, or not. We always get a square matrix, 270 by 270, every single time. If for some reason the difference becomes different, so if we get 273 by 271, we will end up with 271 by 271 matrix. Now, keep in mind that this causes loss of information. So we're not only losing the last black line from the image, we're also losing the information in that last line, the non-black information, and the row above it sometimes.